So in our last section, we're really just going over a summary of conic sections, which is really just going to help us with identifying what type of conic you have. So the most general form you're going to see is you can have some x squared terms, some y squared terms. You can have just one of these variables and then some constant over here equaling 0. So the one thing that you need for a conic, though, is you need one of the terms to be squared. If both of them are there, then that's going to be a hyperbola or an ellipse. But if you just have a single square, that's the case of your parabola. So if you're ever unsure of what the conic is, because it might be an equation that doesn't actually exist either, rewrite it in that standard form, and that's going to tell you based on that formula. So all we're going to do is identify the type of conic without graphing it. Don't need to find any of that information, just what am I dealing with? So here I've got x squared, which is positive, minus y squared, which is negative. The numbers underneath don't matter at all in our case because it's just a hyperbola. One positive square minus the other. If this square wasn't here, then it would be a parabola. If we look at this next one, x squared over 4 equals 1 minus y squared over 4. It might be tempting because you have a minus here to say this is a hyperbola, but really if you add that to the other side, you're going to see this thing is an ellipse. So I've got different numbers underneath. It wouldn't be a circular shape. If I turn to this next example, though, and add this other piece to the other side, we're going to notice it's exactly the same number under here, which doesn't typically happen for an ellipse. So this one has the same value. So if I go ahead and multiply this by 16, we're going to get x squared plus 3, x plus 3 squared plus y plus 2 squared equals 16, which is exactly the equation of our circle. So just be careful. You want to make sure, are these numbers the same or are they different? That'll tell you whether it's the ellipse versus circle. So in this last example, we can cheat a little bit. You got a positive x squared term, a negative x squared term. It's going to be a hyperbola. So I don't need to put this in standard form because if I do, I might have a positive value or a negative one over here. Doesn't matter for a hyperbola. That would just switch which way this opens along in. In the case you have a circle or an ellipse, you need to make sure you put that in standard form before you can truly identify what's going on. So let's go ahead and still get practice with putting it in standard form. We need to complete the square on each of those variables. So I'm going to go ahead and I'm going to group the x's, group the y's, and then move the 19 to the other side. So here I need to take out a 6, and that's going to leave me with x squared minus 2x. Over here, I need to take out a negative 6, and that leaves me with y squared plus 4y. And then on the right-hand side, we still have that 19. So to complete the square on the x's, I need to add a 1, but I didn't just add a 1, I added a 1 times 6. So on the right-hand side, I have to add 6. Complete the square on the y's, I've got to add 4, but again, I didn't add 4, I added negative 6 times 4. So really here, I'm going to do negative 6 times 4. So now we can complete the square. That's going to give us 6. That factors into x minus 1 squared minus 6 times y plus 1 squared equals 1. And if you did want this in the most standard form, you divide or move that 6 into the bottom as 1 over 6. So now you can see that, yes, indeed, it is a hyperbola. So if you're ever unsure, make sure you put it in standard form.